All right, everyone, I think I'm going to start now. So welcome to the Community of Practice Superfund Research Program uh, webinar series. This is our chance to get together over lunch and just have a discussion about some of the ongoing research that is of interest to all of us in the area of PFAS. And the idea is to keep it short, to keep a limited number of
tell you about our next upcoming meeting, which will be on March 3rd at this time, and it'll be Rachel and Rosemary talking about non-chemical stressors and cumulative risks. So please join for that one as well. But what I want to do today is I want to talk about a project that we've been working on related to PFAS for a few years now. I've presented some of this at our annual meetings and at prior events, so some of you have already heard this. So I want to really use this time to kind of synthesize some thoughts and not get into this method. So we've been working, and this is the work of Ned Antel's PhD dissertation. Ned was supervised by me and Lisa.
Co-supervisors. But what we've been working on is this project on selective quantification of charged and neutral perfluoroalkyl substances and their use in the total oxidizable precursor assay. And this particular paper, the second paper from Ned's dissertation that's been completed, is in press at Environmental Science and Technology. It'll be an open access publication, so everyone should be able to get access to it when it comes out sometime next week. And what I want to do today is I want to really not focus on the method itself, but share some of my thoughts on its implications and maybe some ideas about how we might go about integrating it into research or how it relates to research needs. So you can see the list of co-authors here and the title of it, and so you can search for this online. And like I said, it should be out on the website in about a week or so. And if anyone wants an earlier copy, you can ask me. So the motivation for this work is that we had developed the total oxidizable precursor assay, or the TOP assay, about 10 years ago or so, or maybe it's 12 years ago now. And this was a way that, because so many of the PFAS compounds that are present in industrial waste and AFFF in the environment, et cetera, are not possible to directly quantify because we lack analytical standards. We had this idea of the TOP assay where we would just take these compounds and oxidize them, and most of them were oxidized and converted into the corresponding chain length carboxylates. And so we could turn the polyfluoroalkyl substances into their carboxylate compounds. But when we thought about this, we realized that it would be possible to get additional information on the nature of these precursors if we used a selective solid phase extraction prior to the oxidation step. And this method really is a way of loading compounds from a water sample onto a wax cartridge, or the normal kind of wax cartridge that we use to extract PFAS, and then separating into anionic, cationic, and neutral fractions. What we refer to here as a neutral fraction also includes the zwitterionic compounds. And when you read the paper, you can see the analytical method and how this is done. We can do this with aqueous samples. We can do this with soil extracts, and it works pretty well. And that's what mostly the paper's about. But I wanted to look forward into some of the research and tell you a little about what we learned from it. So one of the things that we learned is if we took samples of aqueous film-forming foams and subjected them to this assay, the signatures of the AFFF looked quite different depending upon the source. As you may be aware, AFFF was made in two different processes, and one of those processes, the one that was patented to 3M, has very high concentrations of PFAS in it and other sulfonates. But the precursors, which are at about the same concentration as the sulfonates, primarily consist of cationic compounds, cationic surfactants, and some anionic compounds, whereas the other AFFF, the ones that were used by other companies to get around 3M's patent, consists mainly of compounds that eluted in the neutral fraction, in this case, the zwitterionic compounds, and then a compound that we've studied before called 6,2-F-tab. It accounts for a lot of these compounds. So you can see that the assay gives us interesting information on the source of AFFF. We've also applied this new assay to looking at municipal wastewater. So we sampled a sewage treatment plant in the Bay Area. We sampled the wastewater coming into the treatment plant and the treated wastewater leaving in the effluent. And what you can see is that the wastewater influent primarily consisted of a mixture of anions, cations, and neutral compounds. And when you add the precursors up, their concentrations are much greater than that of the measured compounds, but they're primarily in the short chain, the butyl compounds is what we detect in the influent. And when we look at the effluent, those precursors have gone. They've been converted to their corresponding carboxylates, and there's only a small amount of the anionic compounds left. And we saw this over and over, and we've sampled residential wastewater, we've sampled wastewater from different industrial sources. And I wanted to kind of maybe spend more of my time looking at just this one figure here from this research. And this is kind of a complicated, and it's going to take me a moment to walk you through it, but I think it'll be the place where we'll jump off for a discussion. So first, I want you to look at the left-hand side of this figure and the potential importance of various industrial sources. And so what we saw is that in terms of the total concentrations of PFAS compounds and the precursors, when we look at the wastewater coming from residential sources, you can see that little pie chart that says 150 nanograms per liter next to it. Primarily, what we see are short chain precursors, and the concentrations are, relatively low, around 150 nanograms per liter. But we also see some long chain precursors. That's the filled in grayish bar, and then some PFCAs, both the long and short chains. And then we can sample industrial sources. You can see in this case, I've drawn pie charts for a sample collected from a truck washing facility and a sample from a large municipal airport. And their concentrations were about 50 times higher than the concentrations of the PFAS from residential sources. So they're very high concentrations of PFAS, as we all know, that come from airports and some kind of commercial facilities like this truck wash. Again, they mainly consist of these short chain precursors. There are some long chain PFSAs, things like the hexane sulfonate and the PFAS. And then there are some long chain PFCAs. So these concentrations are considerably higher than the drinking water scale. But when we account for the flow of wastewater coming from the airport and the truck washing facilities and other kinds of industrial sources, they're really small. So even though the concentrations in these industrial sources are quite high, they're such a small fraction of the flow that when we start looking at which sources are responsible for what we measure in the wastewater coming into the sewage treatment plant, it's mainly coming from industrial sources or residential sources shown here. So if you look at the right-hand side of this slide, the part of the blue and the red pie charts, what you can see is concentrations of the long and short chains. So the left-hand pie figures are the long chains, the right hands are the short chains. And what you can see is that what's coming into the wastewater treatment plant, greater than 80% of it is coming from residential sources. If we start by looking at the PFSAs and PFCAs, these are the things that we measure when we send a sample out to the lab and we don't use the top assay. So you can see that, for example, the PFSAs in the municipal wastewater are only about 7 nanograms per liter total. 4 nanograms per liter are the long chains and 3 nanograms per liter are the short chains. The PFCAs are only about 8 nanograms per liter. Again, most of those are the short chains. But if we look over at the precursors, we have about 140 nanograms per liter of precursors coming into the sewage treatment plant, and they're mainly short chain compounds, much higher concentrations, 140 nanograms per liter versus 13 nanograms per liter of the long chain. And again, just about everything is coming from the residential sources. And so in terms of like some considerations of places where we as a group might work together on research in the future, or some of the open questions, is first of all, that we've seen decreases in concentrations of PFAS coming into municipal wastewater treatment plants, but they still contain the long chain PFAS, that is those compounds for which there's drinking water MCLs, at concentrations above the EPA's MCL. So we're seeing concentrations of PFAS dropping over time, but if you think about municipal wastewater, which is the source of a lot of our water recycling programs, which are being discharged to our surface waters, there still are plenty of long chain PFAS there. And these long chain PFASs are mainly coming from residential sources. When we look in treated wastewater from a large sewer shed in the Bay Area, we see that the residential sources account for over 80% of the loading. So at least in some of these larger systems where we have a pretty good handle on what the industrial contributions are, the industrial contributions are tiny compared to the residential contributions. And I think that the main issue I want to get across here, and I want to put out as a challenge to our community, is that California is starting a very important experiment on residential PFAS sources. That is where we have these new regulations to get PFAS and PFAS precursors out of consumer products. And we would expect that both the PFAS and the PFAS precursor concentrations in the municipal sewage coming from residential sources is going to decrease over time. That was the point of one of the benefits of trying to get these things out of commerce. And what we're not doing now is we don't seem to have a good plan to continue to monitor these compounds. That is, the monitoring that was done by the San Francisco Estuary Institute, for example, doesn't seem like there's a plan to keep doing that over time. And I think that we have an opportunity with our relationships with our municipal utilities to continue to do that source monitoring to see, to understand the efficacy of these programs. And then finally, the tools that come from this approach, this approach that we've developed for the we call it the mixed mode solid phase extraction top assay. I think these could be very useful to us as we turn our attention away from airports and AFFF, away from municipal sewage treatment plants, and start thinking about agricultural sources of PFAS and PFAS contamination, and industrial sources and their tracking. And so I think these are things that I was hoping would be interesting to our community of practice. And with that, I'm happy to take questions from people. I'm hesitant to stop sharing at the moment, but well, let me stop sharing so I can see any comments that people have in the chat, or any questions that people want to ask. So again, we have about 15 minutes for questions and answers, so I'm happy to entertain questions that people have. Is that too intense for a Monday morning? Yeah, Cindy.
Yeah, thanks, David. That's very helpful introduction and presentation. So I just have a question about how do you know the abundance of some of the sources you mentioned, like truck washing? Do we have a comprehensive list of where those truck washing facilities are, and do they all operate at similar volume and intensity, or do you expect some of them to be a little bigger, a little smaller? I guess airports are easy to count, but I'm just wondering some of the others.
We worked with one of the local utilities that has an excellent source control division, and the way I understand the way these source control operations work is they have so-called SIC codes or industrial use codes for different types of wastes, and they have them categorized. And so it's largely educated guesses about which kinds of activities are likely to have PFAS. And so they chose truck washing facilities because they figured that there were all kinds of waxes and chemicals used both for the trucks themselves and sometimes possibly even inside of the trucks that were used that would show up. And they do see this. So, the focus has been on truck washing facilities, metal plating shops, airports, and anything that involves servicing vehicles like that. And it's only as good as the individual source control program. And my experience is that the larger utilities can be better at this than the small ones.
And do we have any I won't call it metadata, but more like auxiliary information about the size of those operations?
Yeah, well, they know from the NPDES permits what they typically discharge. I think the concern is that not all facilities that get categorized as truck washing facilities are servicing the same kinds of trucks, the same way that not all plating shops are using the same sort of plating operations, and some may have almost no PFAS in them and others may have very high concentrations, and that's really a challenge for us. So I think one of the things that I think is useful is that this particular study, we sampled residential trunk lines of sewage from neighborhoods where we didn't expect any industrial sources, and the signature, both in terms of the total PFAS and the precursors, looked very similar, whether we were in wealthy neighborhoods or lower income neighborhoods. And so I suspect that if you saw wastewater with higher concentrations of PFAS and PFAS precursors, you would want to go and start looking for an industrial source, because it seems so consistent among residential sources that I don't think you'd find higher concentrations coming from a household operation unless the household was doing something funny.
Yeah, sounds good. Thank you.
Thank you. Okay, Dinah in the chat. Were you expecting to see relatively high proportion of PFBA in the truck wash, airport, and wastewater samples? Yeah, I think that what we tend to see is that most of the commercial products are moving to short chains. So this is this kind of overall trend that we're seeing, that fewer and fewer products in commerce have C6 and C8 chemistry, and I think we could expect to see a lot more C4 and ultra shorts in the future. So that's what I expect. But again, we need to monitor this over time. Jinsu.
Hey, David, nice talk, very informative again. I wasn't quite clear about because I missed a couple of SFEI meetings, but that's why I wasn't very clear why they stopped monitoring PFAS in the Bay. Is it because budget issue, or the declining was so obvious? So
no. Don't. They're definitely continuing to monitor in the Bay. I think what my understanding from folks I've talked to, and I need to confirm this again with Diana and the folks at SFEI, is they did this wonderful sewer shed monitoring where they did the top assay and they measured concentrations coming into the wastewater treatment plants. And my understanding is that there's not really support or a plan to continue to do that over time. And it's not really in their mandate. If the concentrations are coming down, they have a limited budget. Their mandate is to protect San Francisco Bay. I think that the folks at the state level who put forward these safer consumer products bills and of trying to get this stuff out of the supply chain are really interested in knowing if getting PFAS out of personal care products and out of different cleaning products is going to have a noticeable effect on PFAS and wastewater, because PFAS and wastewater determine whether it's an issue for water recycling or for agricultural reuse or for contamination of groundwater. And I feel like it's like a missing thing that the state has an opportunity to do with a relatively small amount of money.
Thank you.
Yeah, John Jacob.
Yeah. So I had a question. Have you guys looked into dry cleaning? I'm going to call it effluent dry cleaning or laundry mart effluent, because that's something
Interesting.
I'm interested in looking at here in Hawaii.
Yeah.
Because a lot of these fabric, they're coated with PFAS for various reasons, including stain proofing. So I was just wondering if that's something you guys are interested or planning to look into.
Yeah, so I know of some publications where researchers have, washed stain-resistant garments, and they measure the leaching. Maybe you've read the same ones. Ned Antel, during his PhD, was doing some work with carpets and fabric washing, and I think he did try some commercial laundries. I don't know if they'd be considered dry cleaning operations, because dry cleaning is usually, I don't know what they use these days. Is it supercritical fluids or what? But Ned had a little bit of data there, but we didn't pursue it. I think it's a good idea to be looking at it. I also would encourage you to look. I didn't show it here, but we have some data from our local utility on commercial laundries, because a lot of these uniforms and things that go to those operations could have high levels of PFAS precursors, and they weren't that much higher than what we were seeing from the truck washing facility and the airport.
Interesting. Thank you.
Okay, great. Let's see, from Kathleen, does the paper talk about SES similarities? That's especially interesting since biomarker levels are often higher in SES groups, but maybe this will be changing. Kathleen, SES, help me out, someone. Anyone help me out? I'm not sure.
Socioeconomic status.
We weren't sampling people, right? So but we did do residential sewage, or rather our partners sampled the residential sewage from the hills and the flats. So here in the Bay Area, the hills tend to be synonymous with higher socioeconomic standing, and the flats tend to be lower income. And the concentrations of PFAS and PFAS precursors in the wastewater were very similar, indistinguishable. So I don't think, at least in terms of what's going down the sewer, we don't really see like wealthy people using more personal care products, or people lower socioeconomic status having higher for some reason. They all look very similar. Okay, 1227. Any other questions or comments from the group? Please feel free, if you can't find that ES&T paper when it comes out, or if you'd like a copy sooner, I could send you something to see. We're looking forward to seeing everyone at the next meeting in March. Okay. Wendy asked, do you use a longer list of PFAS than the 40 on 1633? Wendy, Ned finished this work about 1.5 years ago, so we were still using the prior method, so we didn't have this longer list of compounds. But we're interested going forward at seeing this. So the answer is no. Okay, Leona, last minute things to share with people? Cleona, yeah.
Hi, David. No, just the reminder for the next one, as you mentioned, on March 3rd, which is Rachel and David, non-chemical stressors and cumulative risk.
Great. And Junsu, one last thing.
Oh, good. My honor. Yeah, thank you. David, I remember you guys, the graduate student, tried to look into some optimization of TOP method in the past. Have you guys ever improved your efficiency of the total oxidizable precursor method?
Yeah, so we have these this is the second paper. The first paper, which Katerina published, is out already, and I'll send you.
That'd be great.
I'm not sure.
Yeah.
I'm not sure improving it is but we definitely we're working with folks at EPA in Cincinnati to try to make it to help them as they develop an EPA standard method for the top assay, and have tried to address some of the things that people working with commercial labs have noted as concerns of their users in the past. So I think the EPA method is on its way out, and I can put you in touch with Jean Van Buren, who used to be an SRP trainee working on that, and she's now an EPA staff member working on it. But I don't know that it's actually made it through the whole internal review process. But at least our paper may satisfy some of your curiosity.
Yeah, love to see that. Thank you.
Okay, cool. Great. Good seeing everyone, and see you next month.